Hi everyone, today I will talking about the dot products in vectors. This video is system thinking in engineering mechanics statics, and this one is for your request. So the dot products is the directional multiplications, go beyond the repeat countings, and it may apply the essence of one item to another. The dot products can be defined as the same line of directions acting together like this, which equal to 1. So if we have a dot b here, we can write down it as ax bx and then plus ay by and then plus ac bc if it is in the three-dimensional system. Or you can say that it's equal to the magnitude of vector A multiplied with magnitude of vector B and then cos theta, if the theta is the angle between these two vectors. So let's see if we have u equal to 4t and then b equal to t5. So u dot v will be equal to 4 multiplied with 3 plus t multiplied with 5, which is 12 plus 15, so it is 27. And if you see the graphics of two vectors here, so it is 3 4t here, this is the vector u, and then t5 here, this is the vector v. And because they can define in terms of two definitions, so we can use these two definitions together to find out the angles between these two vectors by using u dot v equal to the magnitude of u and magnitude of v cos theta. So cos theta will be equal to u dot v over the magnitude of these two vectors. So we have already known that u dot v is 27, and then the side of u, which is square root t square plus 4 square, will be equal to 6, and then for v it is 5.83. So we can get the cos theta of these two angles will be equal to 0.771. If you take the arc cos here, you will get the angle is equal to 39.6. So it shows that this one is 39.6 like this. And you also can find out the project component of any force along the lines. So let's see this question. They give you the 300 force acting on the bracket. The magnitude of find out the magnitude of the project component of this force acting along the line OA. So it means that we want to find out the project component, which I would like to use the dot product F and then the 1 unit of OA, or you can say that we want to find out by using the sine of F multiplied with 1 and then cos theta, if you know the cos theta between F and then the line OA here. So let's start with find the force. This force is the two angles system, but they give you the difficult angle to see, so you have to write down some line here, and then this angle will be equal to 30 as well. So F, we will use the cosine angle first, so we will use with this one, F cos 30 will be this term, and it is already on the y-axis, so it should be J here. And then if you do the F cos, F sine, you will get this component F sine 30. So you have to use again with this angle. So for this one, we will get F sine 30 and then cos 30, which is on the c-axis. Okay, and then the last term is F sine 30 sine 30 again. This one will be on the x-axis and this one will be the minus. So for all this term, we may write down that F is t100. So F is minus t100 sine 30 sine 30 I, and then go on, which I have already put it in the calculator. You will get minus 25i plus 295sj and then plus 129.9k, like this for F. And for R, the second step is we have to find out ROA, which I will use the method that I have already taught you. So I will start with O here and go on the lines of exit until I find out the A here. The first line is t100 in y-axis, so it is J, and then minus t100 in terms of x-axis or vector I. And then for the last step here, you have to find out in both x and c here, which is minus t100 sine 30 I and then plus t100 cos 30 k. So I will put all of this in the calculator and then rearrange it. So I will get minus 450 I, which come from minus t100 minus 150 here, and then plus t100j and then plus 259.8k. So to find out the component, you may use two steps. The first, you may use two methods. Which one is easy for you is okay. You can use cos theta in terms of the component will be equal to the sine of f multiplied with 1 and then cos theta. or you may find out the whole term of U of R OA to use the concept of F dot U, and these two you should get the same answer. Let's start with the 1 unit in the line of OA. So we have ROA here. We will find out the size of ROA, which is square root of 450 square plus 350 square plus 295.8 square. I put it in the calculator, so I will get it 599.99. So I will load it up as 600. So the U vector UROA will be equal to minus 450 over 60 I plus 300 over 60 J plus 295.8 over 60K. And then I will use the vector F dot with this vector U, which I will get minus 75 Fx multiplied with Ux minus 450 over 600, and then plus 259.8 Fy 300 over 60 over 600, and then 129.9 295.8 and 600. So this term will be 56.25 plus 129.9 plus 56.25, which is equal to 242.2 n. So if you use the 1 unit method to make the dot products, you will get the project component of F on the line OA equal to 242.2. So let's see if you want to use the cos concept here. You know that if you put F dot ROA here, you will get minus 75 multiplied with this one is from R, and then plus 259.8 multiplied with 300, and then the last term is 129.9 multiplied with 259.8. This is Fy, this is Ry, and for on Fx, Rx. So this term you will get 145,383.02, and then you know that F dot ROA will be equal to the sine of F and then the sine of R cos theta. So cos theta will be equal to F dot ROA over their magnitude, which is 145,438.02 over 500, the magnitude of force, and then 600. This cos theta will be equal to 0.808. And if you want to find out the project components on the line OA, so you can use the concept of 1 unit and then you use the cos. So it will be equal to force 300 multiplied with 1 of 1 unit, and then 0.808, which is equal to 242.2 as well. So if you want to know the components on any line of force, so you can use the dot products. See you next video.